Hey, welcome back to another edition of Microsoft Azure AI Fundamentals AI-900. We are on Azure AI Engineer Learning Path, and this is Salil, your NVIDIA AI practitioner. So we were on Module 2 of the AI-900 course, and Module 2 is Computer Vision. We have completed the fundamentals of computer vision in the last episode, and we'll now be taking on the fundamentals of facial recognition. And with that, let's get started. If you have any questions or concerns, feel free to leave it in the comment section down below.
Fundamentals of facial recognition. Face detection, analysis, and recognition are important capabilities for artificial intelligence (AI) solutions. Azure AI Face Service in Azure makes it easy to integrate these capabilities into your applications. Introduction. Face detection and analysis is an area of artificial intelligence (AI), which uses algorithms to locate and analyze human faces in images or video content. Uses of face detection and analysis. There are many applications for face detection, analysis, and recognition. For example, security. Facial recognition can be used in building security applications, and increasingly it is used in smartphones' operating systems for unlocking devices. Social media. Facial recognition can be used to automatically tag known friends in photographs. Intelligent monitoring. For example, an automobile might include a system that monitors the driver's face to determine if the driver is looking at the road, looking at a mobile device, or shows signs of tiredness. Advertising. Analyzing faces in an image can help direct advertisements to an appropriate demographic audience. Missing persons. Using public camera systems, facial recognition can be used to identify if a missing person is in the image frame. Identity validation. Useful at ports of entry kiosks where a person holds a special entry permit. Next unit, understand face analysis. Understand face analysis. Face detection involves identifying regions of an image that contain a human face, typically by returning bounding box coordinates that form a rectangle around the face, like this. With face analysis, facial features can be used to train machine learning models to return other information, such as facial features such as nose, eyes, eyebrows, lips, and others. Facial recognition. A further application of facial analysis is to train a machine learning model to identify known individuals from their facial features. This is known as facial recognition, and uses multiple images of an individual to train the model. This trains the model so that it can detect those individuals in new images on which it wasn't trained. When used responsibly, facial recognition is an important and useful technology that can improve efficiency, security, and customer experiences. Next we'll explore Azure AI Face Service, which provides pre-trained models to detect, recognize, and analyze faces. Next unit, get started with face analysis on Azure. Get started with face analysis on Azure. Microsoft Azure provides multiple Azure AI services that you can use to detect and analyze faces, including Azure AI Vision, which offers face detection and some basic face analysis, such as returning the bounding box coordinates around an image. Azure AI Video Indexer, which you can use to detect and identify faces in a video. Azure AI Face, which offers pre-built algorithms that can detect, recognize, and analyze faces. Of these, Face offers the widest range of facial analysis capabilities. Face Service. The Azure Face Service can return the rectangle coordinates for any human faces that are found in an image, as well as a series of attributes related to those faces such as accessories, indicates whether the given face has accessories. This attribute returns possible accessories including headwear, glasses, and mask, with confidence score between 0 and 1 for each accessory. Blur, how blurred the face is, which can be an indication of how likely the face is to be the main focus of the image. Exposure, such as whether the image is underexposed or overexposed. This applies to the face in the image and not the overall image exposure. Glasses, whether or not the person is wearing glasses. Head pose, the face's orientation in a 3D space. Mask indicates whether the face is wearing a mask. Noise refers to visual noise in the image. If you have taken a photo with a high ISO setting for darker settings, you would notice this noise in the image. The image looks grainy or full of tiny dots that make the image less clear. Occlusion determines if there might be objects blocking the face in the image. Responsible AI use. Important. To support Microsoft's Responsible AI standard, Azure AI Face and Azure AI Vision have a limited access policy. Anyone can use the face service to detect the location of faces in an image. Determine if a person is wearing glasses. Determine if there's occlusion, blur, noise, or underexposure for any of the faces. Return the head pose coordinates for each face in an image. The limited access policy requires customers to submit an intake form to access additional Azure AI face service capabilities, including the ability to compare faces for similarity, the ability to identify named individuals in an image, Azure resources for face. To use the face service, you must create one of the following types of resource in your Azure subscription. Face. Use this specific resource type if you don't intend to use any other Azure AI services, or if you want to track utilization and costs for face separately. Azure AI Services, a general resource that includes Azure AI Face along with many other Azure AI services such as Azure AI Content Safety, Azure AI Language, and others. Use this resource type if you plan to use multiple Azure AI services and want to simplify administration and development. Tips for more accurate results. There are some considerations that can help improve the accuracy of the detection in the images. Image format. Supported images are JPEG, PNG, GIF, and BMP. File size, 6 MB or smaller. Face size range, from 36 by 36 pixels up to 4096 by 4096 pixels. Smaller or larger faces will not be detected. Other issues. Face detection can be impaired by extreme face angles, extreme lighting, and occlusion, objects blocking the face such as a hand. Next unit, exercise, detect faces in Vision Studio. Exercise, detect faces in Vision Studio. If you have an Azure subscription, you can use Vision Studio to explore the capabilities of Azure AI Vision. Note: if you don't already have one, you can sign up for an Azure subscription, which includes free credits for the first 30 days. Launch the exercise and follow the instructions. Detect faces in Vision Studio. Vision solutions often require AI to be able to detect human faces. Suppose the fictitious retail company Northwind Traders wants to locate where customers are standing in a store to best assist them. One way to accomplish this is to determine if there are any faces in the images, and if so, to return the bounding box coordinates that show their location. To test the face detection capabilities of the Azure AI Face service, you will use Azure Vision Studio. This is a UI-based platform that lets you explore Azure AI Vision features without needing to write any code. Create an Azure AI Services resource. You can use Azure AI Face service with an Azure AI Services multi-service resource. If you haven't already done so, create an Azure AI Services resource in your Azure subscription. In another browser tab, open the Azure portal at https://portal.azure.com, signing in with the Microsoft account associated with your Azure subscription. Click the Create a Resource button and search for Azure AI Services. Select Create an Azure AI Services plan. You will be taken to a page to create an Azure AI Services resource. Configure it with the following settings. Subscription, your Azure subscription. Resource group, select or create a resource group with a unique name. Region, East US. Name, enter a unique name. Pricing tier, Standard S0. By checking this box, I acknowledge that I have read and understood all the terms below. Selected. Select Review plus Create, then create and wait for deployment to complete. Connect your Azure AI Service resource to Vision Studio. Next, connect the Azure AI Services resource you provisioned above to Vision Studio. In another browser tab, navigate to Vision Studio at https:// Locate the file named store camera. Next unit, knowledge check. Knowledge check. 1. How does the face service indicate the location of faces in images? A pair of coordinates for each face, indicating the center of the rectangular bounding box around the a set of coordinates for each face, defining a rectangular bounding box around the face. 2. What is one aspect that might impair facial detection? Glasses. Extreme angles. Fast shutter speed. Extreme angles. 3. What two actions are required to try out the capabilities of the face service? Create an Azure Cognitive Search resource and open Vision Studio. Create a face resource and open Vision Studio. Create a face resource and open Azure OpenAI Studio. Create a face resource and open Vision Studio. Correct. The face resource has face detection's capabilities and can be used in Vision Studio to understand its capabilities. Summary. While Azure AI Vision and Azure AI Video Indexer offer face detection features, the face service and associated APIs provide more capabilities. Which you should choose will ultimately depend on the insights you want to gain from facial detection. If you want to look for data around facial landmarks, the face resource is the best choice. You can find out more about the face service in the service documentation. Cleanup. It's a good idea at the end of a project to decide whether you still need the resources you created. Resources left running can cost you money. If you intend to study other modules in this learning path, you can keep your resources for use in other exercises. If you have finished learning, you can delete the resource group or individual resources from your Azure subscription. In the Azure portal, in the resource groups page, open the resource group you specified when creating your resource. Click Delete Resource Group, type the resource group name to confirm you want to delete it, and select Delete. You can also choose to delete individual resources by selecting the resources, clicking on the three dots to see more options, and clicking Delete. All units complete.
So with this, we've now completed Module 2.2, which is Fundamentals of Facial Recognition. And we are free to proceed to the next section, which is Fundamentals of Optical Character Recognition, or OCR. So I hope you enjoyed this session. If you have any comments or questions, please feel free to drop them in the comments section below. We look forward to seeing you in the next one. Ciao.